Good morning, Year 10s. How's it going, guys? We are doing amazing on the register already. We are only missing 4 people. We're missing Anna, Toby, Ben. There's Anna. Look at this. We're nearly done. 3 people. Toby, Ben, and Con. That's it. That's the only 3 people missing. That's amazing. 3 people. Yeah, there we go. Sounds working great. Yeah, only 3 people missing. Morning, everybody. Morning, Ruby. It's nice to see you, Ruby. Thanks for coming. Yeah, so Con's not here. Oh, is Con not coming when? Okay. I'll mark Con as missing. Just Ben and Toby to go. I'll mark Ben and Toby as missing. And then when they show up, I'll add them to the register. Okie dokie. Right, guys, let's crack on. Oh my God, the goatee is gone. Yeah, I finally got fed up of it, Isabel. It was like, it needs to go. It needs to go. The lockdown goatee is gone. Okay, guys. Oh, look. Salamat pagi. There's Ben. Just Toby and Con who aren't here now. Amazing. Okay. Let's crack on, folks. I like it. Share screen. Can everyone on the chat, please? Did everyone manage to get the homework done? I know that I'm not giving you an awful lot of time. You know, if you can't do it or you haven't got time, don't worry about it. Yeah, you guys know me and you know me well. You know, you don't need to worry. If you can't do it, it's not a big deal. It's really not. Thanks, Rue. Look at that. Yay. Cool. Right. Let's crack on. So the first thing I'm going to do is going to do a really quick review of the homework. And then we can crack on. Oh, Vic. Thanks, Vic. Right. So it was a nice, easy start. This is just simply getting you guys to apply your rules that I gave you from NAG, SAG, PMS, and Castro Bear. Yeah. So the first rule is everything is soluble except for the exceptions. So what I would have, of course, have always done is ticked them all like this and then gone, right, where are my exceptions? Lead sulfate, there's the exception, PMS. We know that PMS applies to both the group 7 salts and the sulfate salts. So that one now becomes insoluble and lead sulfate is white. And then we've got silver chloride, another exception from PMS. Yeah, silver. Silver is an exception on the group 7 and the sulfates as well. Can I just point out, by the way, silver actually ticks a whole load more boxes. Silver is basically not soluble really except for the nitrate. Yeah. All fluorides are soluble as well, by the way. There's another rule for you. You can add to your notes as a nota bene. All nitrates and all fluorides are soluble. But silver chloride is a white precipitate, and ammonium carbonate is soluble as well. It's actually very soluble, about 100 grams per 100 centimeters cubed of water. It's very soluble. I always know that one because it's 100 and 100. Yeah, it's one of the ones I know. Sorry about that. It's just me being nerdy. As you do these, you just kind of pick up these oddities when you're making them. So, okay, and so guys, 4 marks. Yeah, first section is out of 4. Should have been nice and quick. 4 marks for the first bit. Right, now this then becomes so much harder. Yeah, these questions here are kind of a love 5 because it's based on knowledge. Yeah, this is knowledge recall. Then this is a huge step up. Yeah. So, and the great thing is there's 2 different levels. There's the word version and then the symbol. So the word equation is sitting down there at a love 4, but then the symbol equation is up there at a love 7-8. It's a much harder, and with state symbols, it's a love 8-9. Yeah, it's tough, this. So we've got sodium sulfate and barium chloride. There's a rule. We know the rules for equations. If you're not sure, swap the metal. It's always useful. If you can't see an acid base, yeah, if you can't see a combustion, swap the metal. It's a great rule. So I'm going to form barium sulfate. Just swap the metal. Barium sulfate and sodium chloride. There's 1 mark for you guys. Nice, easy word equation. You only write a word equation when they ask you for it. If they don't, if they just say write the equation, you're writing a symbol. You guys are at GCSE stage now, not key stage 3. Right, we've got to do all the translation out into symbols now. So sodium sulfate, Na2SO4. If you want the reminder of how you do this, yeah, Na is in group 1 plus 1. Sulfate is SO4 2-. You've just got to know that. Then you do your cross and down. We're going to need one sulfate and 2 sodiums. Yeah. Now sodium sulfate, all group 1 salts are soluble. So that's going to be aqueous. Barium chloride. Now barium is part of Castrobare. And Castrobare is about the sulfates. So barium chloride, which is BaCl2. I'm actually going to shrink my pen and make it a bit thinner. There you go, BaCl2. And let's look at how we did it. We got Ba2+ from group 2, and then chlorine from group 7. That is completely built through the periodic table. Just a reminder of how I'm doing it. Barium is here, it's in the +2 column, and chlorine is over here in the -1 column as chloride. Yeah, +1, +2, +3, +4, -4. And then it switches over, -3, -2, -1, nothing for the noble gases. So cross and down, need 2 chlorines for every 1 barium. Barium, of course, is in Castrobare, and that's only for sulfates, so it's aqueous. Group 7s are soluble. So then we've swapped over. We're going to get barium sulfate. There's your Castrobare. Now you need a state symbol of a solid. Yeah, and we're also going to form sodium chloride, which will be aqueous. All group 1s are aqueous. Yeah, all group 1 salts. And now we just have to balance for it. And I think we're done with a 2 there. I'll put the 2 so it's not overlapping with the number. Oh, yeah, overlapping with the line. There we go. And we're done. That's it. So guys, that's hard, that. What I'm going to say is I'm going to give you 2 marks for this. I'm going to give you 1 mark for the balanced equation, yeah, and then another mark for the state symbol being solid on the barium sulfate. Obviously, it's for state symbols across the whole thing. Yeah, aqueous, aqueous, solid, aqueous. By the way, you can have those 2 reversed. It makes no difference. So 2 marks, though, I think is very reasonable for these equations, considering how hard they are. I think that's very reasonable. Next, swap the metals. Yeah, so I'm going to have silver is going to take potassium place. Potassium is going to take silver's place. So we're going to have silver chloride. Yeah, silver chloride and potassium nitrate. Can't switch into symbol. Potassium sulfate. There's the word, level 4. Yeah, and then equation with state symbols, really much harder. AgNO3. You're going to come across silver nitrate a lot, so it's worth knowing. All nitrates are soluble. Yeah, potassium chloride, KCl. All group 1s are soluble. Now I'm going to get silver chloride, PMS. Yeah, silver halide, silver sulfate, silver carbonate's insoluble, silver sulfate's insoluble. Potassium, thank you. Thank you, Kieran. Potassium nitrate. Thank you very much. Thanks, Kieran. Yeah. And then, yeah, so silver chloride is one of our exceptions from PMS, isn't it, nitrate? Thanks, Ruby. Thanks, Kieran. And then we're going to get KNO3. All nitrates are soluble, so it is aqueous. On the chat, please, what is the color of silver chloride, please? What is the color of silver chloride on the chat? And Tong is in the room. Tong, I asked you this last time this made an appearance. If you want to prove that the precipitate was silver chloride, what do you need to add? Yeah, let's see if she can remember, folks. I wonder how many others can as well. Yeah, this is technically not GCSE, it's A-level. But it's really nice to gain that. Well done, Ben, smashing the color. It is a white precipitate. Well done, Ben. Add dilute. Isn't that awesome? Look at that. That's lovely. Tong said ammonia solution last time, but then she's now made the correction. It has to be dilute, Ashley. To prove the white precipitate, you must use dilute ammonia. That's a white PPT, and it is proved. Yeah, this confirmation test is dilute ammonia to confirm, and it will redissolve. Yeah, redissolve. That's A level 3. Nice to have that though. By the way, that's also AQA GCSE, just so you know. Right, next one. Okay, swap the metals. Let's go back to red. So I'm going to get ammonium nitrate. Ammonium nitrate. All nitrates are soluble. All fluorides are soluble. If it's AgBr, it's conc, right? Yes, that's correct, Ashley. And the cream precipitate would redissolve. Well done. Ammonium nitrate and calcium carbonate. There we go. Calcium carbonate. What the heck? Come on, Mr. Dumb. It's early in the morning, isn't it? Calcium carbonate. Calcium carbonate. Okay, on the chat, please. What is the chemical test for the ammonium ion, please? What is the test for that guy? What is the test for a calcium ion? And what is the test for a carbonate ion? I'd love to see more chemical tests. It's just nice to see them, innit? Innit, lad. Yeah, I've lost my mind. Oh my goodness. Okay, this is actually now beyond A level. Does anyone know what the chemical test for the nitrate ion is? I may have mentioned it once. It's a long lost, forgotten test. Right, so the ammonium carbonate is Na. This is hard, because it's two complex ions that you have to know. Just to remind you of how I've built it. The ammonium ion is NH4+. The carbonate ion is CO3 2-. I'm going to need 2 ammonium ions to cancel out the negative charge. Ammonia is warm. Then use damp litmus paper and turns blue. Ben, you've missed a step. Kieran's fixed it for you. The test for the ammonium ion is add sodium hydroxide, add NaOH, and then you warm it, and then you use damp red litmus paper. Yeah, damp red litmus turns blue. Yeah, it's always lovely to do the week. Isn't it cool how Ashley smash. Oh, calcium orange. I love that. He just gives orange red. Yeah, calcium is a flame test, orange red. Well done for that. Ashley, Kieran, you didn't actually say the word flame test, just throwing it out there. But you're right, carbonate, add acid, effervescence. Well done. This is flame test. Isn't it cool how everything ties together in chemistry. You can start mixing and matching these kind of things all the time. Flame test, and you see orange red. Yeah, on the flame test. The carbonate ion is add acid. Dilute sulfuric is usually the one to choose. Yeah, although if it's you've got to watch out for any precipitates that may form with the metal. Add acid, and we will see effervescence, but I can't spell it, so I'm just going to say fizzing. I can't spell effervescence. No, neither can I, Ben. Lol. Nah. Does anybody know the test for the nitrate ion? It's hard, that one. It's a long lost, forgotten test. I may have said it just in passing. Yeah. The test for the nitrate ion, which is long lost and dead. Yeah. The test for this is Devada's alloy. Yeah. Devada's alloy, which is a mixture of aluminium and zinc. Devada's alloy, it might actually be spelled without an R. I can't remember. Devada's. It is Devada's. You say Devada's, but it might be without the R. Devada's alloy. Aluminium something. Oh, look at that, Ashley. Well done. I read it somewhere. Oh, that's so cool. Well done. It is an alloy of a mixture of aluminium and zinc. And what it does is it converts the nitrate ion into ammonia. That's what it does. And guess how you finish off the test? Damp red litmus paper. You actually warm it. Warm, damp red litmus, and it turns blue. Isn't that cool? It's nice to be able to see how the ammonia gas test is super handy. Yeah, really nice that. Right, going back to this, so there's ammonium carbonate with calcium nitrate, another tricky one because of the complex ion. Yet calcium is in group 2, nitrate is NO3 minus. Remember, you've just got to learn your complexes. Crossing down, I need 2 nitrate ions to get rid of the positive 2 charge. Right, swap over. So we now get ammonium nitrate. Now, ammonium nitrate is cool because it now becomes just that. That's actually, by the way, ammonium nitrate is genuine fertilizer. Yeah, artificial fertilizer. Yeah, that's what we make in order to feed plants. We want lots of nitrogen for them, you see, for protein synthesis. Yeah, so that's fertilizer. So ammonium nitrate, and we're also going to get calcium carbonate. There we go. And we now need to balance it. We need to, I think that's it. Is that it? Wow, that's it. We're done. State symbols. All ammonium salts are soluble. All nitrates, all ammonium salts are soluble. All nitrates are soluble. All nitrates are soluble. Guys, this one you needed to know. I didn't mention this last time. You guys must know that calcium carbonate is an insoluble solid. That's one of the ones that you just got to know. Yeah, it's important, that one, because it's limestone. Next, 2 marks, folks. So we're going to have 1 mark for the word equation, 2 marks for the symbols, all the symbols being correct, and then the last mark for the state symbols. Next, swap the metals. Yeah, so we've got sodium chloride becomes sodium sulfate. All group 1 salts are soluble, so that's going to be aqueous. And then I'm going to form copper 2 chloride. Need the Roman numeral in the words. Yeah, copper 2 chloride. There we go. Let's now do your state symbols. Yep, so we've got sodium chloride. That's going to be aqueous. And then we get copper 2 sulfate, which is CuSO4. Copper 2 sulfate is aqueous. It's blue in water. You guys all know that. Then you form sodium sulfate. All group 1 salts are soluble. So that's also aqueous. And then this one is not in your rules. And it is soluble. Yeah, that is not in your rules. All of them were aqueous. No precipitates here. Which means doing the ionic becomes almost impossible. In fact, you're going to laugh at this. It almost does nothing at all. The ionic equation for that. Oh, you haven't done ionic equations. It's A-level. Forget it. Don't need it. Lead nitrate will become lead iodide. Oh, sorry. 2 marks. Oh, is it balanced? I didn't balance it. There we go. Balanced. Oh, see, it's always good to check. 1 mark for the words. 1 mark for the symbols. 1 mark for the balanced equation with all the formula being correct. Next, lead nitrate becomes lead iodide. Lead, technically 2, but it's always a 2. Lead 2 iodide. Yeah, and then we're going to form potassium nitrate. I dropped straight into symbols. It's quite hard for me to do that. Potassium nitrate. Potassium nitrate. What have I gone and written there? Nitra. I don't know. Nitrate. Okay. Just a quick, why not? What? Okay. On the chat, please. What is the chemical test for the sulfate ion? SO4 2-. What's the chemical test for it? What's the test for the chloride ion? What's the test? Oh, really good one. Hard question. Yeah. On the chat, please do it separately. What is the 2 tests for copper 2+? Copper 2+ has 2 tests. What is the test for the sodium ion, please? Look at that. We can test for everything now. It's boss. Loving it. Add sulfuric acid, you'll see fizzing. Test for what? No, Tong, that's a carbonate ion. You're talking about the sulfate. No, that's not correct, Tong. That's a carbonate ion. Fizzing is carbon dioxide. Chloride is halide test, which is silver nitrate. Rue, I want more details, please. Come on, that's not enough. There are 2 steps in that test, Rue. Come on. 2 steps in the sulfuric acid one as well. Come on. Copper 2 is flame test, blue-green. Well done, Ben. He's got 1. Ben is the first person to give me a correct answer. Thank you, Ben. Hero. Flame test, blue-green. Thank you, Ashley. In agreement. I love it. So we can test for this with a flame test. That's test number 1. Flame test. Blue-green. Yeah, blue-green. Ah, well done. Tong has said a oh, there you go, Ashley. And there's the NaOH one. Yes. Look at that. Great. Ashley, well done. Second test is sodium hydroxide, blue precipitate. Well done, Ashley. Blue PPT. She's on her tests. Nitric acid, then silver nitrate, white precipitate. Thank you, Rue. That's better. Add nitric acid, followed by silver followed by silver nitrate, and we're gonna see a white PPT. Yeah, white PPT of AgCl, one of our PMSs, because it's a white solid. So how do I, oh, someone gave me, well done, Tong. Add HCl and barium chloride, you see white, thank you. Sulfate ion, add hydrochloric acid, HCl first. Yeah, add HCl, then you add barium chloride, and you see a white precipitate of barium sulfate, one of our Castro bears. Yeah, BaSO4 insoluble salts. How do I, then the sodium ion, of course. And sodium ion's not a complicated one, is it? We know that. Hang on a sec. Sorry, one of my laptops isn't charging. Don't know why. But, not for one. Oh, no. That's bad news. Oh, that's interesting. It's not charging. Maybe it's not plugged in properly. Oh. No, it is actually. Oh, not charging off that charger. That's bad news. What? It is plugged in properly. It is. There you go. Oh, they're both charging now. That's weird. That charger didn't want to work with the other Surface Pro. That was weird. NA flame test yellow. Thank you so much. Oh yeah, it turns blue. See, it's good to do all these kind of recaps on tests. Okay, next equation. 1 mark for the words. That's awesome. So there we go. So what is the test for the iodide ion, please? What's the test for the iodine ion? What's the test for the potassium ion? What's the test for the nitrate ion? I'm teaching you it now, folks. Sorry. Yeah, you don't need it, though, but it's nice to do it. Test for the iodide ion. I'm going to ask Ben for this one. Yeah, Ashley knows PPT in chemistry is precipitate, also PowerPoint. Aha! That's very true. Do you know what? That's a good point, actually, Ashley. You're not allowed to use PPT in the exam. You have to write down the word precipitate. But you're right, it is also PowerPoint. That's a bit of a tricky one. Do you know what? I've never actually made that link before. Okay, let's now... We know that lead is always 2+. It was on our list of ions to learn. PBI2. Yeah, plus Ki. No, made a mistake. It's nitrate, brackets, NO3, brackets twice. Ki, swap the metals. That becomes lead 2 iodide. Lead is always 2+, by the way. It's nice to know. Add silver nitrate, yellow precipitate. Ruby, there's 2 steps in the test for the halides. Can I just point out, your color is perfect and your silver nitrate is correct, but what goes first? I test is same as Cl, just beige. No, it's not beige. It's not cream. It's not cream. Ruby's correct. Ruby, you're absolutely right. But the iodide one, of course, don't forget, whenever you're testing for the halide, same as the chloride, you add nitric acid first. That destroys the carbonate ions, because otherwise you get a white precipitate of silver carbonate. And then you add silver nitrate. Yeah, I think you're actually allowed to write for the add nitric acid to remove impurities. And you will see a yellow PPT, spot on. Yellow PPT of silver iodide, a precipitate. Yeah, it's one of our PMSs. Next. Still haven't had the test for the potassium or the nitrate. Next, we're going to get potassium nitrate. All nitrates are soluble. Let's add on our state symbols. All nitrates are soluble. Aqueous. Ki, all group 1s are soluble. Lead iodide, PMS, lead, it's a solid and it's bright yellow. Potassium nitrate, of course, all nitrates are aqueous. Lilac flame, thank you, Shanley. Flame test, lilac, well done. It's always good. Yeah, flame test, and we see lilac. Well done for knowing your color. Yeah. Right, so once again, 3 marks. Yeah, 1 for the equation and 1 for your state symbols. Last question on the worksheet. Oh, I thought I'd throw in a curveball here, guys. You haven't done this one in a while, have you? Are you going to form lithium hydroxide? Any metal plus water, you form a hydrox. You form the hydroxide and hydrogen. Yeah, it's a great rule from our equations lessons. It's convert to symbols. Yeah, so 1 mark for that one. Guys, what is the test for hydrogen gas, please? What is also the test for water? What's the test for H2O? And what color would I see with universal indicator for hydroxide ion balance equation? Oh! I'm embarrassed. I'm sorry. Thank you, Ashley. Squeaky pop test. Well done, Kieran. Good job. Yeah, test for hydrogen. Squeaky pop test. Light it on fire. Fire! And then you'll get a squeaky sound. Squeaky pop sound. Ah! Squeak. It's got all the vowels in it. It's so rubbish. I can never spell it. Q-U-E-N. Squeaky. Squeaky pop. I don't know. Whatever. What's the chemical test for water? Who can remember? Let's convert to symbol, lithium metal. That's easy. Oh, it's a solid because we know that all metals are solids. We're going to add it to water. That gains a state symbol of L. I'm then going to form lithium hydroxide. All group 1 salts are soluble. And hydrogen gas with a G. Balance the equation. Ooh, 2, 2, and 2, I believe. I think that now adds up. Yep. Water, add anhydrous copper sulfate turns blue. Ben is on it. Ashley, well done. Kieran, well done. Goes from white to blue. That's great. You guys know I'm so proud of you guys. So proud. So proud. Right. 1 for the equation being balanced correctly and 1 for the symbols. I definitely lost 1 mark on this because I forgot to balance, didn't I, Ashley? So I would have lost 1 mark on that exam, that worksheet, definitely. 1 for that one, 2 for that one. Cool. Look at that. What a fun thing that was. We did all of that. That was amazing. So we had 3 for this, 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 and 3 for this. Total number 18 plus 22. So that's 18, isn't it? No, 12? No, 9, 18. So there's 18 for that section. Total, tattle, nice. Total, 22. So out of 22, guys, fill in your worksheets, fill in your data, and see if we can find the data. Hello, data. Oh, no, plug the cable again. Oh, no. Oh, that's not a good thing, that. It's not charging properly. Oh, no. It stopped charging again. Oh, that's a bad sign. It's not a good sign, that. It's not a good sign. It's only on 78%. It should be charging. Oh, how interesting. It's really weird. Had to swap chargers again. Really strange. Oh, it's not charging on this one either. Uh-oh. Oh no. I think I might have broken a charger. Oh no. I think my charger might have died. Eek. Uh-oh. Anyway, let's move on. So, I know, right, Rue? Rue knows exactly how that feels. Why is there an ambulance near your house? Okay, the reason for that is we live right near a golf course, and every time there's lightning, it gives a warning. That's why. That one, and then that one. See you guys putting in your start year 10 homework data sheet. Yay. TPC. No, it's the Tropicana one. We live right by Tropicana Golf Course. Can I make this? Ooh. Uh-oh. Whoa, that's weird. Oh, it's done. It's just slid me right over on the stupid bar. There we go. I'm gonna zoom out a bit so I can see everybody. It just says working. Laptop's really struggling at the minute. I think it might be my internet. I don't know. It just continues to say working. There we go. But then it won't let me zoom out anymore. Isn't that stupid? I feel like I want my keyboard back. It's pulling out all the cables left, right, and center. Really irritating. Let's go zoom right out. There we go. That's better. Hey, look at that. Okay, numbers going in. I love it. That's great. I hope you found that useful, folks. Yeah. It's nice to see that people, I mean, it's great that people aren't getting them all right. You know, it's all about storm alarm there. What happens if it just drizzles? I don't know, Shan. If there's no lightning, they don't give it. It's just a lightning one, lightning bell. Be like in school. It's really lovely to see all your data in, guys. It's great. Isabel, are you there? Isabel, you're missing 2 homeworks. Toby, who's I don't think actually is here. I don't think Toby's here, is he? No. Oh well. Isabel, are you there? Can you post on the chat, please? I feel like you're walking away, Isabel. I am here. Oh, hi, Toby. Toby, you're missing 3 bits of data. I'll fill it in now. Thank you, Toby. Really appreciate that. Isabel. Isabel. Oh, someone message Isabel and tell her that I'm here and I'm asking for her and she's meant to be in the lesson. Grr. When you've got 2 bits of data missing, yeah, worthwhile filling them in. Isabel has just wandered off. Totally wandered off. Right. Okay, guys, we're on to salt preps now, folks. So we've got a good amount of time as well. Salt preps won't take very long. Finishes at 10. Got 20 minutes. That's great. Okay, so let's see if I can find my pen and crack on with salt preps. Isabel. Isabel. Yeah, that's right. You've been caught. Yeah. Okay, title for today's lesson. Make my pen a bit fatter. Practical salt preps. Right, now, I'll actually put preparations, yeah, and preparations. So this is, I'm going to just translate this into English, yeah? This literally translates to salt making, yeah? Salt making. The word preparation means to make in chemistry. Is this the rock salt experiment? Shanley, no, it is, but it isn't. It's way beyond that. The rock salt practical you did in Key Stage 3 and in Year 9, I think we redid it in Year 9, that's purification. Where you dissolved it into water and then you filtered it to get rid of the rocks and then you evaporated to get the salt back. The tail end of that is the salt prep, but there's practical steps here that we need to look at if we're going to do this properly. So, what does practical salt preparation mean? Yeah, salt making. We want to make pure, dry. We want to make pure, dry salts. Now, the reason why I'm underlining these is because each one of these is got a step specifically for that. So, okay, we've got to look at this like a thought experiment. We can't do real chemistry. By the way, you would just do this in chemistry. This isn't very easy practical to do. Yeah. So now the first thing I need to mention is there are 3 different types, which is a bit of a nightmare. There's actually 2 major types and then 1 subdivided. Yeah. So we can do, in fact, hang on. 3 salt prep methods. Now, they are all very similar, and you'll understand why, because they're all making salt. Yeah. Now, it's actually split into 2. So we've got making soluble salts. Soluble salts. Since we missed out so many experiments, do we have a full week with just experiments? Ben, I'm pretty sure I could sort that for you if you wanted. We've got making soluble salts, and then we've got making malking. I don't know what malking is. I've done it again. Making insoluble salts. Now people go, so there's 2. And I go, no, there isn't. The reason being is the soluble salts is split into 2. Yeah? Because we want to either make hydrated salts or anhydrous salts. Yeah? So hydrated, let's just remind ourselves, this means, yeah, calcium chloride dot 4 H2Os. Yeah, we want to keep the water trapped inside. Yeah, hydrated salts, water trapped inside. Yeah, or we've got anhydrous salts where it's just CaCl2. Yeah, or now these are both going to be, oh, hang on, yes. Yeah, that's fine. I can easily do that for you guys. We have done so much theory and no practicals. We'll just do experiments for a full week. In fact, whatever days we've got left, Ben, we will just do practicals every lesson. I'll be done with the theory for year 10, so we can just do practicals every lesson. Yeah, I'll sort that. We'll do some really cool ones as well. So making insoluble salts. Yeah, and by the way, both of these, of course, yeah, well, they're both going to be solids. We're making solid salt here. I'm just going to get rid of the other bracket. It looks like I'm trying to put brackets right inside the formula. Yeah, and then this one's something like lead iodide. Yeah, which is a precipitate. Yeah, insoluble. Okay. So 3 methods, and unfortunately, guys, the best way I can teach is to teach you like a generic one that you guys can then adapt. And what I'm going to actually do is I'm going to actually write down all 3 side by side, and then you can see the differences between them. I think that's the best way of going about this. So methods. Yeah, methods. So since I've now linked the salts up here to the different methods, let's use those. Yeah, method. So we're going to get 3 methods. Number 1, we are going to form anhydrous. That means without water. Anhydrous calcium chloride. Method number 1. I'm actually going to use a ruler. Why not? I've got a ruler. I'm going to use a ruler. Method number 1. Winner. Method number 2. Method number 2 is we're going to form hydrated, hydrated calcium chloride. Both of these are very soluble, by the way. Dot 4 H2O. So we're going to make that one. Ruler. And the last method is we're going to make lead iodide because it's insoluble. Yeah, number 3 is lead iodide. Yeah, number 3, PbI2. Yeah, there's no hydrated in this. Yeah, lead iodide as a solid. And I'm just going to quickly write underneath that insoluble. Yeah, it's worthwhile kind of having that in there. Okay, So let's look at our methods. So how are we going to do this? Well, everyone would probably agree. This is actually an issue here because the lead iodide is going to stand out. What I'm actually going to do is I'm just going to divide this one here because these two are going to be related. Yeah, these two methods are going to be similar because we're making the same salt, just in a different outcome of whether or not we want water trapped or not. So, okay, these two are going to be similar. This one's going to be very different. So the first thing I'm going to ask, right, year 10, step 1 is mix blank and blank. Right, guys, what am I going to mix together to please? If I wanted you guys to make me calcium chloride, what are you going to want to put into the beaker, please? You're going to go into your chemistry store cupboard. You have no calcium chloride. You need to make it. What are you going to grab from my chemistry store cupboard to make that salt? Go. Gonna make that a little bit. Chlorine and calcium. Holy moly, Kieran. Really? Chlorine gas? Toxic chlorine gas? No. Okay, you could. But guys, I don't own chlorine gas. That would be madness. That would be crazy. Or some chloride salt. No, Rue, you can't. You need to make pure. Yeah? But like calcium being more reactive, you can't because you're going to end up with two salts mixed together, Rue. Then displaced. No, you can't, Rue. Oh, you can't? Okay. Oh, because you're going to get sulfuric acid. Kieran, if you do yours, Toby has just given me the correct answer. Thank you, Toby. There is another alternative that I will accept. Yeah, like what Toby said. Yeah, so we're going to need, the key things here are, I need an acid. I'm going to need HCl acid. Yeah, I'm going to need hydrochloric. So, okay, mix hydrochloric acid, and now you guys chose calcium metal. Calcium metal is very, very reactive. Like quite scary reactive, really. I don't think I'd really want to throw it into hydrochloric acid. It would probably catch fire, potentially. So what could I use instead? We could use calcium solid and they would allow it. Yeah, we could use calcium solid. But I'd like an alternative, please, something that would be safer. So we could use, but we have to use hydrochloric. Yeah, calcium solid or, come on, guys, you've got an acid, you need a base. Come on. Give me another calcium base that you know. I've already seen at least one of them today. Come on. Come on. Calcium oxide. Thank you, Ashley. I like that. Could be calcium oxide. Give me another one that you've seen today. Yep, calcium oxide would work, Ashley. It'd be far safer than calcium metal. Like, then you get salt and water. Yes, but I only have water. Water's easily got rid of. Yeah, thank you, Ruby. Thank you. So hard. Calcium carbonate. Thank you, Ruby, for saving the day. Ashley, Ruby, you have done so well today. I'm so impressed. Thank you, Tong. Spot on. Right, now the reason why you choose these is because, guys, you're only making one salt and water and maybe CO2. CO2 is going to leave as a gas, and the water is going to just be able to be evaporated. Yeah, this is not complicated. I guessed, but thanks. No, it's good. We said it. We've mentioned calcium carbonate today. That's great. Ruby, I think you're starting to realize that you've made 2 guesses today and got 2 correct. Chemistry is about being able to make those connections, and you're starting to get a good understanding of this. It's good. Yeah, so we're going to mix these 2 together. That's going to be 1 mark in the exam. Yeah, now let's go to the hydrated one. We're actually going to do exactly the same step. Yeah, step 1 is we are going to mix. Yeah, mix HCl, and I'm going to put calcium or calcium oxide or calcium carbonate. Yeah, that's going to make me calcium chloride in solution. It's going to be in water. Yeah. Now, how do we make sure, step 2, how do we make sure that the reaction finishes? Step 2, Yeah, we've mixed it together. How could we make sure that it's all used up? Because would you agree, you can't have leftover, you don't want to boil acid. Yeah. So the step 2 is just making sure it just mix the hydrochloric acid. Yeah. And then what would we, the questions, I've stuffed up the question really. Yeah. Yeah, we will make sure add base. Yeah, add base. Now these are your bases. Yeah. Yeah, add base in excess. Yeah, add base in excess. Now the reason why you do that is done. I'm going to change my color for red. This is important. So all acid is gone. Yeah, what you don't want to have happen here, folks, is for you to, when you get down to the point when you need to drive off the water, you're going to boil acid. Not a good idea. We're going to add the base in excess. Add base in excess. Yeah, you can copy over the other bit if you like as well. Right, so what do we now have? What does it now look like in a picture? Here's what this now looked like. We had a beaker. It had acid in it. It had hydrochloric acid in it. Loads of hydrochloric acid molecules. Yeah. What we then did is we then added, let's stick with the ease. Let's stick with the easy one. Let's say we add calcium solid. Yeah, the calcium solid will react. It'll turn into gas. Metal plus acid, salt and hydrogen. Yeah, we're going to get calcium plus HCl. Yeah, is going to form calcium chloride and hydrogen. Don't forget to balance. Yeah, and the hydrogen gas is going to leave. This is great. Now, if we add the base, in excess, yeah, would everyone agree what's going to happen to the size of this calcium if it's in excess? Yeah, that's the calcium. By the end of the reaction, all the hydrochloric acid is used up, but there is going to be a small amount of calcium left over. Yeah, this is calcium left over. Right, how do I now remove that solid that's been left over? Step 3. Yeah, step 3. Filter. Yes, well done, Rue. Filter solution to remove excess base. Yeah, in this case, calcium. Excess base / solid. Yeah, because the base one in it was a solid. Let's do the same thing. Step 3 is the same. Filter. I'm just going to write filter. Filter to remove excess base. I'll put solid. There we go. Right, now we've got to this point. Now that we've done that and we've filtered, yeah, filter, we now have a beaker of only calcium chloride and water, aqueous. Right, we need to get the salt back, and this is where things are going to differ. This is where things are going to deviate. Yeah, one of them needs to be anhydrous. Yeah, so with anhydrous, we need to remove all the water. Yeah, step 4. Evaporate until solution until almost dry. You can't say dry. If you say dry, you'll lose it because it's dangerous to evaporate till dry. It spits. Until almost dry. Yeah, you're evaporating about 95% of the water off until almost dry. Just a nota bene there of danger. Will spit if full evaporate, full evap. Yeah, it will spit. Right, now, doing really well here, folks. Step 5. Right, this is where they deviated because this one, I want some water to remain spit. Yeah, spit. The solid spits out of the evaporating dish. Pachoo, 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 spits everywhere. Yeah, spits. This one, we want to leave water. So step 4, evaporate. I'm nearly run out of time. Evaporate until a saturated solution is reached. Test with glass rod. You take a glass rod and you touch it on the surface, and if crystals form immediately, because the glass rod is cold, by the way, reduces the solubility and the crystals appear. Test with glass rod for crystals. Right, now we're at kind of a similar stage here, guys. Yeah, because now what we need to do is, so evaporate until almost dry. Leave to fully dry in drying oven. In drying oven. There you go. Technically, we haven't done the purity step. Yeah, almost dry. We should then, the problem is they're soluble. You've got to be careful with washing it. Wait, like you prod it with a glass rod, then crystals will form on the rod. Yes, Ashley, that's exactly right. Because the solution is saturated, and as soon as you add that cold glass, the crystals instantly form on the glass rod. It's quite a fun practical. You'll enjoy doing this. Yeah. Test with glass rod. Right, now for this one, number 6, leave in, leave to cool down. Leave to cool down so crystals form. So crystals form. Filter out crystals. Dry with paper towel. I know it's mad, isn't it? Lots of steps. I know, guys. Dry with paper towel. I know. It's long. It seems awfully long, but when you do the practical, it kind of actually just kind of makes a bit more sense. The lesson has run out. It's 10 o'clock. It's 2 minutes to 10. I'm gonna have to let you guys go, I think, and we haven't done the insolubles. Wait, so for the one that you evaporate until saturated and the other is almost dry, how would you know? Oh, okay. Ashley, I can tell you that. So here's what it would look like. Here are the two. Yeah, we have got, this is my solution. I'm going to make the anhydrous here. Yeah, anhydrous. And we're going to make the hydrated over here. They started off at the same point. Yeah. But what you're going to do is with the anhydrous, you're going to evaporate this. Yeah, you're going to heat it until it gets to like here. Yeah. All of this water here evaporates. All of it. Down to about the last 5%. And what will then happen is, because it's still hot, it will continue to evaporate when you leave it somewhere warm. The water will leave and you will get because you've got rid of 95% of the water. You cannot form the hydrated. You can't. With the hydrated, you evaporate it down to about here. Yeah, you evaporate about 60%, give or take. You just until you know when you reach a saturated solution, you can't really miss it. Crystals start to form on the surface even when it's hot. You know when you get there. And then once that water's gone, yeah, this is now a saturated solution. You touch it with your glass rod and crystals immediately form on the surface. And then you just leave this to cool. Now, when that cools, yeah, when it cools, the water is still there and the crystals grow. Yeah, the crystals grow inside it like this. And then you've got to filter out. They're hydrated because there was water there for it to be trapped in the crystal still. It's cool, that. This one just ends up as a white solid. Yeah, it's a bit rubbish. Guys, it is the end of the lesson. I have gone a full hour. I'm so sorry. I think I should have just done the homework super quick. Isabel. Can someone message Isabel for me? Isabel, she just abandoned me. She's signed in. That annoys me. It's upsetting. Very upsetting. Right, guys. Have a lovely weekend, guys. It's Friday. You guys had a homework yesterday. No, I'm not going to give you a homework. Have a nice weekend. Enjoy it. See you later, guys. It's lovely to see you as always. I'll see you soon. Last bit. So if you heat the saturated solution too much, then you can accidentally make anhydrous. Yes, that is absolutely right, Ashley. Yeah. See you later, guys. See you later.